Okay, so when we're looking at these triangles, Taha was asking, do we find the proportion? Well, we're trying to prove these triangles guilty of being similar. So we can do that in one of three ways. We can do it by angle, angle, squiggly, which we would not set up a proportion. We can do it side, angle, side, similarity, which we would set up one proportion with two ratios. Or we can prove it by side, side, side similarity, and then we'd have to set up three ratios in our proportion. So yes, you would need to check the proportion, Taha, definitely, to prove them guilty of being similar. George, what'd you get for number 1? Y'all are going to put a question mark after it every time, just for your insurance, just in case you're wrong. You're like, well, I didn't really know the answer. All right, so in number 1, we can definitely add arcs to our picture. Arc, arc. This is what your quiz is over today, by the way. Remember, we have 3 quizzes this week. Your quiz is over all 3 of these. I mean, this warm-up is literally your quiz, except there's more problems on your quiz than just 3, okay? This is just like your quiz. So I added angles because I know that those are vertical angles. Then I'm going to compare the sides, and I'm going to put small over small and large over large, okay? So the smallest number, I'll do second over first because we're used to that. The smallest number here is 9. The smallest number here is 3. The largest number here is 15, and the largest number here is 5. Does 9 divided by 3 equal 5? 15 divided by 5? Yes, absolutely. You get 3 both times. So those 2 purple triangles are guilty of being congruent by side, angle, side similarity. If you leave off the similar symbol, you get it wrong. So you may not write side, angle, side on your quiz. You have to put the squiggly. Number 2, Brandon. What'd you get on number 2? There is no X and Y, Yeji. Brandon says none, so let's check him to see if he's correct. We'd want to put small over small, medium over medium, large over large. So let's pick the smallest one from here, 7. Smallest one from here, 2. Medium one, 14. Medium one, 4. And large, 18. Circle it. And large, 5. So you would divide those out. If you really wanted to, if you weren't sure, you could do 7 divided by 2, and you get 3.5. You could do 14 divided by 4, and you get 3.5. And then 18 divided by 5, and you get 3.6. Ah! Does the order matter, Yeji? I don't know what you mean by order, but you have to put the small over small, the medium over the medium, the large over the large. Can you put the large over the large first? Sure. But can you put the large over the medium? No. So these were so close to being similar. They're like a smidgen off from being similar. So that's correct. We would write none. And number 3, Hussein. What'd you get for number 3? You do not have to put second over first, Yeji, because I don't see the word scale factor anywhere. So I was putting second over first just to stay consistent, but you absolutely don't have to put second over first. No, you don't. Hussein says none. Okay? There was a homework problem like this, and I worked it in my video of homework problems, except the problem was different on the paper than on the screen. Anyways, not a big deal. Right now, as it looks, we cannot determine. Right now. But we have a little bit more work to do. Uh-oh. Okay. Oh, that's a flattering. Don't look at that. Okay. Come on. Okay. So, we've got some math to do. These are both right triangles. And this one looks like it could be side, angle, side. And this one is angle, side. Oops, but we're missing this. So let's find that side real quick. Let's find that side. 25 squared, oh, minus 15 squared. It's a Pythagorean triple, so that's good news. But my computer went out again. So our missing side is 20. Now, we could potentially have side angle side, but we have to check our proportions, okay? Is 20 over 9 the same as 15 over 12? We have to check it. Can't assume. So 20 over 9 is 20 over 9. It doesn't reduce. And 15 over 12, you know, reduces to 5/4. So Hussein was totally correct. The answer is none because those did not end up being proportional. But they could have been proportional, so we did have to check. We did not do extra work. We did have to check. Is everyone okay with that last one? It was kind of weird. We had to find the missing side using Pythagorean theorem. Then we had to check our proportions. Oh, I see it now. Did I do something wrong? I see it. 20 is the biggest and 12 is the biggest. Are y'all seeing this? Am I the only one seeing this? You almost let me get away with working this wrong. Oh man. That would have been cool. The answer is side angle side similarity. Were y'all going to let me get away with that? Oh my goodness. Glad I checked my answer before I turned my quiz in. I'm glad I checked my work before I went to the next slide. Did y'all see that? You have to put the large over the large. This triangle's been flipped. You can't trust the order. We weren't given a similarity statement, so we can't trust the order. We've got to put large over large, and we've got to put small over small. And I didn't do that when I originally set it up. I just assumed that 20 and 9 were corresponding because they looked like they were in the same spot. So that was a good lesson for all of us. Yay! Are we okay with the answer changing? What does this mean? It means that I solved it wrong to start with, and then, oh, you're looking at your quiz grade. It's been doing that. I'm not sure, Taha. I didn't email them until 10 minutes ago, Yeji. Here are your homework answer to triangle midsegments. Do you see any problems you want me to go over? $25 and $28. Wait. What are you talking about, 25, 28? 14. What else? What else besides 14? Anything else? 11. 14 and 11. Okay, last chance to ask a question. Last chance. Okay, 17. That's it. 11, 14, 17. Here we go. Okay, number 11. DE is x plus 2, and BC is 1/2 x plus 19. So we learned yesterday that the mid-segment is half of the base. So I'm going to double my mid-segment, and it's going to equal my base. So I can distribute 2x plus 4 equals 1/2 x plus 19. If you don't like working with fractions, then you can multiply everything by 2. You can double everything. So this would be 4x plus 8 equals x plus 38. If you want to get rid of that 1/2, I just multiplied every single term by 2, and I got rid of my 1/2. Now I can subtract x from both sides. Subtract 8. And it was not asking for x, it was asking for DE. So you need to plug it back in, x plus 2, and that's how we get our 12. All right. Uh, 14 was 14 the next one, I think. So the way that you do these is first, you want to cover up the bottom. So in this triangle right here, this is a mid-segment. So we double it to get our base. So our base, and my marker's too thick, my base is 8. Okay, so that's 8. Now I can look at the bottom. And now, actually, in this triangle, this is a mid-segment. Because this is 4 and this is 8. 8 minus 4 is 4, so that's a midpoint. This is 8 and this is 16, so that's 8 and that's a midpoint, 8 and 8. So that red one is a mid-segment. We already said it's 8. A mid-segment is half of its base, so its base has to be 16. So it's like a mid-segment within a mid-segment. It's a double mid-segment. Okay, and then the last one I asked about was 17, I think. You got the wrong homework. Okay, let me make a note to change that. So is this helping by going over these problems or no? Has 30 problems. Okay, the ones that I've worked, are those the same as the ones you had? Just in a different order. Okay. If you still have a question on the one I didn't do yet, I don't know if it's the right number. We'll get that figured out, but we need to teach this lesson so that y'all can take your quiz. All right, so the title of the lesson, and we'll get to the title in a second, is Area and Volume Ratios. But this slide is going to do a quick discovery as to what we're learning today. So if I look at these rectangular prisms, first I can document, oh, and it's really hard to see the one that says volume. You can almost not even see it at all. But anyways, the word volume is there. It's just really light. We're going to document the width, and I don't care which number you use as the width. I'm just going to use 3 and 9. So I'm going to call that the width, and I'll call that the length, but it's not a big deal. Now, let's find the area of just the front of each box. Let's find the area of the front of each box. So the area of that first box, the front of the box, would be length times width, or 3 times 2. So the area would be 6. The area of this one would be 6 times 9, 54. And then, to figure out what we're learning today, we need to find the volume of each box. And so volume is length times width times height. So 3 times 2 times 2. 3 times 2 is 6, 6 times 2 is 12. The volume of the other one, 6 times 9 times 6. 324. And now to the side, we're going to write the ratio. We're not really writing the scale factor, we're just writing the ratio, and we need to make sure we reduce it. So 3 to 9 would be a ratio of 1/3. 6 to 54 would be a ratio of 1/9. And then 324, 12 to 324 would be a ratio of 1 to 27. And what's the scale factor? Second over first, 9 over 3, so the scale factor is 3. So I want you to take a look at the scale factor. I know I'm going quickly, I'm sorry. Take a look at the scale factor and take a look at those 3 ratios. Do you notice anything? This is the 1D ratio, this is the 2D ratio, and this is the 3D ratio, because it's a length, it's an area, and it's a volume. There are multiples, okay? Does anyone else notice anything cool? They're not powers of 3. You're saying it wrong. They all have a base of 3, maybe. They're multiples, yeah. So do you agree if we take our scale factor is 3, right? Our scale factor is 3. There you go. If we take our scale factor, this ratio is 3 to the 1. This ratio is 3 squared. And this ratio is 3 cubed. So today's lesson is, when you find a scale factor, if you want to know the ratio of the lengths, you do the scale factor to the first power, because it's 1D. If you want to know the the ratio of the areas, you take your scale factor and you square it, because it's 2D. And if you want to know the ratio of the volumes, you take the scale factor and you raise it to the third. You cube it, because volume is 3D. Get it? 3 to the 1, 3 to the 2, 3 to the 3. The scale factor is 3. All right, let's look at the summary slide. This is what you would write down on your notes if you take notes. This is today's lesson. If K is your scale factor, you've found your scale factor, second over first, and your scale factor is K, then the ratio of the dimensions, let me give you an example of dimensions. Length, width, height, even perimeter falls in this category. All of those are one dimension, 1D. 1D. So they all fall in the category of just the scale factor. The ratio of the areas, you take the scale factor and you square it. And the ratio of the volumes, you take the scale factor and you cube it. Area would apply to an area of a figure and the surface area also as well of a flat figure or a 3D figure if you're doing total surface area. Okay? I'm going to move on. Let's try some examples. Find the ratio of area and volume for the similar water bottles. So, first we're going to find the scale factor. We're going to find the 1D ratio. So we're going to find the ratio of the diameters. So we're going to do second over first. Second over first. So there we go. The scale factor, unfortunately, is not an integer. It's a fraction. The scale factor is 4/3. Are you okay with that? I'm not sure what you're talking about, Quan. Oh, the notes, it was just K squared, K cubed. That's the only thing, it was just K Okay? Oops, there we go. Okay. The ratio of the areas. So now all we do, I promise, all we do is we take the scale factor and we square it because area is 2D. And then we just make it prettier. So 4 squared is 16. 3 squared is 9. And then you check and see, can I reduce that? 16 divided by 9, math, enter, enter. No. So that's our answer. That's the area ratio. And now we do volume. We take our scale factor and we raise it to the third. So 4 to the third is 64. And 3 to the third is 27. And once again, it cannot be reduced. So those would be our answers. 4 thirds, 16 ninths, and 64 27ths. Okay? To the 1, to the 2, to the 3. 1D, 2D, 3D. Let's try a real-world problem. See if we can apply this. If a similar fish tank is to be produced using a scale factor of 4 ninths, let's stop right there. That's a very large fish tank. That is in Berlin. It has a volume of 800 cubic meters. If our scale factor is 4 ninths, are we getting bigger or smaller? So we want to build the same exact fish tank, but we don't have that much money, so we want it to be smaller, okay? Find the volume of the new tank. There's 2 ways to approach this. There's the scale factor way and there's a proportion way. I'm going to show the scale factor way, but in other problems I'm going to use the proportion way because the proportion will make more sense. But today I'm going to use the scale factor way. So here's my original fish tank. It is 800 cubic meters. I'm going to multiply that by my scale factor. But I've got a problem because my units, meters cubed, that 800, that is in 3D. That's a volume. And my scale factor is just 1D because it's a scale factor. You can never multiply 3D by 1D. Does not work. Can't do it. So I need to make sure that I'm in the same units. 800 is 3D, so I need to make sure that 4 ninths is 3D. And so the way I do that is I raise it to the third. So I'm doing 800 times 4 ninths to the third. Now, you can rewrite that, or you can just go straight to your calculator, and you can plug it in. 800 times 4 thirds to the third. I know I could use the calculator on my computer, but can you see that? You can't see that. Anyways, I entered in 800 times 4 thirds caret third. Okay? And since it's a real world problem, we might want to put it in decimal form, 1896.3 cubic meters. Or if we were asked for an exact answer, if we wanted to be super exact, it would be very ugly. It just depends on what the problem asks for. Oops, I put centimeters, meters, cubic meters. Okay, so all I did in this problem was I cubed my scale factor because we're doing volume. Okay, let's do another one. 2 candy bars have a scale factor of 2 to 7, and the surface area of the mini candy bar is 56 centimeters squared. Find the surface area of the king size candy bar. Are we getting bigger or smaller? Bigger. So we're not going to use 2/7. We want to make sure we use 7/2 because we want to make sure we get bigger. I'm going to do it the scale factor way again. 56 times 7/2. This is 2D, and right now 7/2 is 1D. So I need to make it 2D, so I need to square it. All right, I'm going to go straight to my calculator. 56 times 7/2 squared. And you get 686 square centimeters. So the moral of this lesson is you can't use a scale factor when you're in 2D or 3D. You have to do something to your scale factor. Almost done. Two similar cones have volumes of 216 and 512. If the radius of the smaller cone is 9, what's the radius of the larger cone? Do you see how this time I'm not given a scale factor? I am not given a scale factor. This is what I'm going to solve it doing proportions, and this is going to be the last problem we do because you got to start on that quiz. Okay, so we've got 216 to 512, and the smaller is 9, so I'm going to put that with the smaller. Now, 9 is 1D because it's centimeters, and 216 and 512s, that's 3D because it's a volume. You cannot cross multiply a 1D with a 3D. You cannot cross multiply a 1D with a 3D. We want our answer to be in one dimension. Do you see how X is in the 1D column? So if we want our answer to be 1D, we need everybody to be 1D. We need everybody to be 1D. How do you undo 3D? How do you undo 3D? Very good, George. Very good. You cube root it. Cube root it. So on your calculator, the cube root is under math. Go to math. Mine's number 4, but I have a really old calculator. I'm not sure if yours is the same. Math 4, and then I put 216, and I get 6. Math 4, 512, and I get 8. So 6 is to 8 as 9 is to x. This is 1D and this is 1D. You can reduce it if you want, or you can just go ahead and cross multiply. 9 times 8 divided by 6. And you will get x is 12 centimeters. I wish we could do more, but we can't because we have run out of time. You need to take your quiz.